We all know that looking into the future is very complicated. We all want to know, but nobody knows. And we know that many things are happening and we don't know really what to expect. And it's interesting that when we look into the scientific area, people have realized also in science that looking into the future is difficult. You see here, I've taken it from a presentation in the United States. It says forecasting is difficult. Yes, we know. And then we find ourselves as victim of surprise. It focuses on the United States, but I think it's the same for all of us. So what is the challenge? The challenge is that we have different issues that are behind our view, looking into the future. We have to understand the system. We have to select some methods which help us to look into the future. We have to pick up some data, then we get some forecasts, and we have to interpret it. So it's very complicated. And when we look around what people are doing, and I put together some of those deficiencies, and I've realized it very much. I'm very much engaged in the publication of a journal, and I'm engaged in dealing with PhDs in the universities. What people do is they focus on the methods. They leave the first part out and they leave the last part out. They concentrate mainly on the methods. And we've also realized that most people, even among our colleagues, they know some knowledge, some methods, but only a very few. And then they focus on those few. And what we also realize that the emphasis is too much on old data, but the future is not about old data. The future is about new data. It requires fantasy. It requires ideas. Where could we move? So let's first look into the first part to better understand what I mean when I talk about understanding about the system. So I put together a small example, which I like very much. So let's assume we have some observations of the past. So what people usually do is they take a straight line. And we come back to that later because that's the easiest one. Nobody challenges it. What about this function? Or what about that one? All of them fit the old past observations. So, but depending on what you know about the system, what you think about the development of the system of the future, your forecast looks completely different. So, what? Okay, that was the entrance point, and now we move further into our presentation. We are going to discuss a matrix of methods. Then we discuss about an IT solution. And at the end, and that I like very much, we are doing some experiment where we discuss about Notebook LM. So let's start with a matrix of methods. It's the basis of the project. The project says, okay, you have to put together a matrix of forecasting methods so that we can select from them, and it supports people in doing their forecasts. So we have here developed, and Rolf Müller, my colleague, has been very engaged in developing this matrix. We have put together about 41 methods, and they are linked to about 31 attributes. And the idea is that it should help us in developing forecasts. And you see here to the right, one of those attributes like resource intensity, it has three different realizations, low, medium, and high. But it's not only for the 41 methods, but it's many, many more, because in some of them, there are a few together. So it's a kind of an integrated view. For example, when we look at moving averages, we have three of them in there: simple moving averages, weighting moving averages, and exponential one. So in principle, we have about 60, 70 methods together in this matrix. Now, the first thing I would like to do is to look into the attributes we've been dealing with. We have very simple ones, yeah, like typology. We have a time horizon. We talk about resource intensity, skill requirements, setup time, information type requirements. So they're very basic issues. But there are more things behind it. And that's where we want to focus now on. The attributes that are different from the ordinary. Dragon kings, black swans, gray rhinos, or phase transition. And let's look into some of them now in more detail. What is a dragon king? It's a statistical outlier which is often not looked at because it's considered an error. It's much larger than would be predicted. And we put together some of the examples and especially put emphasis on the mad cow disease. It came out of the nowhere because of hygiene deficiencies. But we have also other ones like an extreme agricultural drought, may lead to catastrophic crop failure, etc. So we have to make sure that dragon kings are not overlooked. Another issue are so-called black swans. It's something which is unpredictable, extreme outliers which we didn't really expect. And some people say that's one of the dangers of relying on historical data, because those unpredictable outliers are not there. And we have some examples, and you see here COVID-19 was something, our war is something that we didn't expect. And then the last one was the trigger of the Irish potato famine, when we had this paid potato problem. But there's a lot of discussion going on black swans, and I put there to the right a heading of a publication which talked about 9 black swans in 2024. Another one are gray rhinos. So they are foreseeable threats. They're highly probable, high impact. They're clear warning signals, but people often ignore them. And I put down there some examples. One of them, when we talk about gray rhinos and physical natural forecasting, obesity in the European Union. Yeah, it's not looked so much. Yeah, we know the risk, but we miss the action. Or maybe a reduction in crop yields due to soil degradation. It might be overlooked. The signs are there. Or when we talk about the inability to irrigate crops, look at southern Spain and other areas. We see the falling groundwater levels, but maybe it's overlooked. Things like that. And then the phase transition is the last in our discussion here. It's a sudden qualitative shift in system behavior. Yeah, it's not expected. See here at the part down there, some species might disappear. Market might crash. And these are issues that are usually not expected. So when we look at the various so uncommon type of attributes, dragon kings, black swans, gray rhinos, phase transition, some of them are predictable, like the dragon kings, but they are much larger than expected and often discarded as error. The other predictable are the gray rhinos, but they are often ignored. When we looked at when we talked about the obesity, black swans are unpredictable, usually considered impossible, like the phase transition, when you had market breakdowns. Now let's look at the methods. And for us, it was clear those different type of attributes need to be considered by those methods. So when we discuss the methods, we want to look first at the different types of forecast approaches. The first one is that we use functional relationship in forecast. That's especially statistical methods. I think we are all aware of them. This is a standard used in forecast. The other one that has come up more is the using drivers. We're looking not at data, but we're looking at drivers. And then people develop scenarios. The drivers influence data, and then we can develop scenarios looking into the future and the development of drivers. Another one is a system approach, where we look at different entities in a system and all the relationships between the different entities. The modeling, the model relationships between the different entities. The first one is that we ask people. Yeah, we call it the human interaction. They sit together and then, okay, they find out about the future. And then we have the large language models, we have the artificial intelligence, and there you have the knowledge cloud, where we try to draw some information about our discussion about developments in the future. So now we look at the different methods. We move further. We have now looked at the different ways people can approach the view into the future. And we put together a type of typology where differentiate four variations, which are distinguished by the information source and the information processor. So we look at human intelligence and system models, and then statistical models and machine learning. The first ones are based on human intelligence. The system models model the relationships between various system entities, and then the other ones look at the data. And then the information processor, it's human mind, that just people are doing something, or we employ a computer. And for all of those methods, we put together documentation. It's documentation has two parts. I just very quickly look into those two ones. Document part one and part two. The first one has a kind of a general discussion about different issues of the methods. We talk about the strengths, we talk about weaknesses, we talk about resources, we talk about applications, and then there are references to it. So it's all put together. And then the second documentation talks about case studies. So it's easy for people to find about case studies and tutorials, so to help them to learn better about the different methods. Now we go into detail. We start with the first type of views into the future, the human intelligence, where people sit together and try to find something out. And there's quite a number of methods. And you see here the red ones and the blue ones. The red ones are those where human mind is the information source. And the blue one is where you rely on information, information that comes from somewhere, custom information or databases. But the information processor is the human mind in all of them. You know some of them. Delphi is a very common one. You know scenario studies. All of you know them. So we don't want to discuss about them. But there are a few I would like to pick up and discuss with you. We want to look very quickly on Fermi estimation, prediction markers, and super forecasting. So you get a little bit of feeling how those methods work. Fermi estimation, what is it? It's not so easy approach. It breaks down a complex future problems into simpler questions. And then it brings people together and they guess about answers to those simple questions. And then somebody puts those answers together into a kind of comprehensive view about the future. And it says, okay, you have to get people together who are able in logical reasoning. A small team with dominant knowledge is sufficient and then can provide a forecast about the future. They say it's especially suitable for situation where data is sparse. Okay, we don't have much data about the past, and not much maybe judgment about future data developments. Super forecasting, that's something where you use individuals who are good at looking into the future. And they say, okay, those super forecasters are identified through their performance in prediction tournaments. So you find those stars and you put them together. And then you say a small team of such trained super forecaster can look into the future. I like this. So we look for those stars and they help us to look into the future. Prediction market is something that is not really used yet in Forecasting, it's used more in the financial area. But we, together with Rolf Müller, we discussed and said that might be an interesting forecasting approach for the future as well. Yeah, participants trade contracts based on the likelihood of future events. So you make yeah, forecasts and you get reimbursed for your forecast. So, and on those platforms, those forecasts are gathered and then put together into a kind of a development because people move towards a kind of a common approach on what the future will look like. And it says participants are motivated to make informed predictions because they profit from their accuracy. So let's see if that will be something to deal with in the future. No, system models. I don't want to discuss about those. There have been discussions in those webinars about the magnet model, which is a typical, and the Capri model is a typical representative for this type of models. So we go to the next part, statistical and machine learning models. The first ones, the statistical ones, were put together. You see here a list, and then various machine learning variations. We are not going to discuss statistical models very much because I think most people know them. That's our standard when we talk about forecasting. And there's also some experience when it comes to large language models. I think most of you have some experience, basic experience on how to use large language models in forecasting or whatsoever. But I would like to look at three of them: ARIMA, LASSO, and large language models crowd. ARIMA. It's a complex approach, and if somebody's interested, Rolf Miller is happy to tell you more about it. It's an approach which combines three components. So it's not one approach, but three approaches together: autoregression, integration, and moving average. So and I think that is one of the things we will come back later on, that you are better off if you combine approaches, if you are not just playing with one approach and that this approach helps me to find out about the future, but you put different approaches together and then you interpret and you put them together and find your forecast proposal. Lasso, it's also something which is very close to statistical models. It's based on a linear regression model. But you do not take all data about the future, but you select data from the for the future. You reduce the value, as you can see here, the value of various data, so that those who are close to zero are not considered in the linear regression later on. And the lesson from those Lasso application is that they seem to better predict the future because they are looking more at variables that seems to be more important than others. And large language crowd is something also very simple. It also applications in the literature that you use multiple large language models and then you integrate the different results into a forecast proposal. Now we move to the next step. When you have so many methods and so many criteria and attributes, you need some help. And that's when we came in and said, okay, let's develop a software solution. Yeah, how to move forward. So in the core, we have the matrix of methods, and they are based on a selection of attributes you see here from the left. And then at the end, what we want to have is that we get a selection of methods that are suitable for what I need. And there are quantitative methods and methods in situations where we don't have data. We looked at some of them. We call them non-data methods. But methods are not everything, so we need some data. So we thought, okay, we need also to put together matrix of data that we say, okay, these are data that can be linked to the methods. And then we have a data source of that can be used for quantitative methods to find forecasts. So we have the methods and we provide some basics for data, pass data, and then we say you have everything you need, and then it depends on you how you move forward. So it's a software design support. So we enter the software, it's not so important, and now it gets complicated. How to start? There are so many methods, and how to get people linked to it. You cannot just provide a long list and so now look at them. And the matrix, it doesn't help very much. So we thought the most important part is that people decide about time horizon. So I move forward. So 1 year, between 1 and 5 years, or 5 years, and then have some principal types of methods they want to look at. And because the whole thing is so complicated, okay, you can start with an information page. Yeah, you click, I go back. You click here, information for moving around, and you get a lot of information, and it helps us to find your way. Now, the key issue is the matrix. Now, let's look at this matrix in a little bit more detail. So we have differentiated between the human intelligence methods, the data-based models, which are the statistical ones, and the machine learning methods, and then we have system models. And you see here the numbers show, okay, how many of the methods belong to those different type of categories. And now people can click in all, so then all methods will be shown. Also can click at one of them. Here we have clicked of the line of 5 years. And that means there are 16 selected methods that are suitable, or parameters suitable for time horizons of more than 5 years. And they are shown to the right. Small picture, you see the names of them, and they represent a small picture. Then there is below the matrix 3 criteria we considered very important for a very basic identification of methods. We talk about the need for resources, the need of skills, and the time it needs to set them up. So this slide shows a click on a different part of the matrix. Now we clicked not on 5 years, but we have clicked on this small square here, which says human intelligence for short-term forecasts. And you see now that there are only 7 methods that are available. So you can move around in the matrix and you get different selection of methods that might help you to look into the future. Now, I go back to this 5-year time horizon with the 16 methods. And you see now that all of those methods have certain colored parts below the picture. And they refer to resource intensity, skill requirements, and setup time. And you can see here, after we have selected them, that in methods with low resource intensity, with medium resource intensity, and with high intensity are all considered here. Now, what you could do here, I can jump over this. I can see we've already discussed it. We click now on low. And what happens here is that you can see the yellow low. The yellow bottom is only shown in some of them. That means that those methods which show this yellow button have a low resource intensity. And those forecast methods where this button is empty, they apparently have no low resource intensity, may a medium or a high one. So there are only now very few ones which have a low resource intensity, low skill requirements, and low setup time. We have in altogether 1, 2, 3, 4 methods that are really where all the requirements are low. And in the others, it's mixed. So, for example, this top down here, this horizon scanning, the skill requirements are low, so it's a blue. But apparently, the resource intensity is not low, and setup time is not low either. So that helps us to very quickly understand how those different forecasting methods are related to those criteria. Now, the next part we could do, we could select some of them. You see here, there's a mark. We marked 4 of them and said, okay, we want to compare them in more detail. And then you get to a page where those 4 which we have selected are described in more detail. There's this text, and this text could be longer. And now we could mark them for more intensive display of their characteristics. So we can mark them, and you see here all 4 have been marked. So all 4 are now considered in a matrix, and this matrix has drop-down parts, so all the criteria can be shown and can be viewed at. Now, when we go back to this initial page, you see here different signs. That's the access to the documentation and the access to the case studies and tutorials. We have looked at them earlier in our presentation. But the more interesting part is now the third sign, this database sign, and it helps us to access databases. So we clicked at one of them and now get an overview of different data sources. We have data sources on food security, we have data sources on biodiversity, and you see here there are differentiated access to food, availability of food, stability of food supply. And when it comes to biodiversity, we have overviews in the biodiversity regions, then international, European, and country type of databases. So if somebody clicks at some of those data sources he or she is interested in, a link to it, you get to lists of data sources. So they include in the center the web address. You have certain database characteristics, so very quick. And then there's a short description to the left. So anybody could click on any of the web addresses and then the database is open. For example, this is an example, global state of food security. It's one of those data. Another one is the Economist Global Food Security Index, which is opened. So there's a European Environment Agency, their data hub. So it's in one of the environmental data or the regions. So you see that you can jump in any of those type of databases. So it's a huge collection. When you look at the top here, we have nine such collections, and in each one of them, so we have about 500 databases that are accessible through this part. Now I go to our last part in the presentation, which I like very much. It's an experimental one, and we would like to add it to our software solution. You all know that in artificial intelligence, there is one development which is called NotebookLM by Google, and there are also some other developments called Open Notebook, which are of a kind of have similar characteristics. And what we've been trying to do is now we put the matrix of methods into this NotebookLM. We took all the references we had in our description of the different methods, put them in there. We put the case studies in there, and we put the matrix of databases in there. So we had about 300 documents we put in there. and now tried out what can we do with it. So I would like to put the focus on four issues when we go through the example. One is that there is artificial intelligence support, which we can utilize. Then there's a value of applying different methods. We also need to understand different approaches, and what we also should be aware of, there's a room for manipulation. So, what was our idea? We were requesting advice now from Notebook LM with all the documents in there. And we said, okay, we want something that helps us to alarm policy about the obesity development in Europe. So provide me with some forecasts that help us to alarm policy. So we made it a little bit more concrete. We said, suggest different prediction methods. They are generally accepted. We don't want to get into a discussion about the methods. They should be generally accepted, so that would be okay. But we want to be able to bend the results if we think that's appropriate, but still working with the generally accepted methods. And it should not take too much in terms of money, time, and skills. So came up with suggested method, linear trend extrapolation, expert judgment, and horizon scanning. That those three methods are most appropriate. They are scientifically accepted. They allow the selection of more dramatic outcomes. That's when we talk about bending, sorry. But they are also remaining low cost and require minimal technical skills. And then the artificial intelligence tool we developed provided us with a strategy. He says, use the established methods while maximizing political impact. The linear trend, they are showing lines going off the chart. It's interesting because they say, you don't have to defend a linear trend. Linear is so accepted. Even if you think that the curve might look different in the future, we take linear. So you can take expert judgment quotes, they interpret the graph and can interpret this as a crisis. And horizon scanning finds examples why this is happening. Now we look at the primary strengths of the different methods I've been selecting. Trend, it creates alarming charts. Experts provide expert quotes. They shield us from blame. And scanning identifies specific scary stories. And bendability, yeah, when you trend, you can start star types and model types. Yeah. We were looking linear, which is not the case probably when we look at obesity. So with experts, we can decide who to ask. And in scanning, we can select reporting alarming signals, ignoring stabilizing trends. Sometimes I have the feeling when I look at those things that some of our climate discussion is a little bit in this direction. That people talk about take strengths, look at bendability, and then tell us about the future. So, but I think we should take two things from this kind of experiment. It's useful to select different methods because they can serve different objectives, but we should be very careful in looking at the forecast and be ready to challenge the approach. Maybe a final slide in our discussion when we talk about policy decision. One thing that came out very prominent that we should choose different methods when we talk about forecasts and then combine them by using probabilities and a more elaborate approach would be that we develop a kind of a sequence of forecasts. We develop a first forecast, and then we look at the results in policy decision making. And then we discuss about what could be done to not realize this forecast. That means how could we identify drivers that could influence development? And then based on this policy decision idea, we develop a new forecast. And so we move towards a future we would like to develop. So finally, what have we been discussing about? We started by discussing about the need for understanding a system. We discussed various issues to deal with outliers. We had the Dragon King, we had the black swans, etc. We discussed about fitting methods depending on what type of data who we would like to engage. We talked about data, the availability of data, and the discussion into the decision process. Thank you very much.